Hello everyone and welcome to another video. Today I'm going to be covering the chapter 15 notes, just the first few slides here, over what a titration is. So we are going to start here. There's actually some stuff that I'm going to be skipping over just because we are not going to be getting to that. So let's just talk about pH, and remember that that is the measure of how many hydronium ions we have, so that H+, H3O+. Remember, if you have a lot of those, you will be acidic and be lower on the pH scale. And if you have very few of those and you have a lot of those hydroxide ions, you will be a base and be higher on the pH scale. Now, specifically, when we're talking about how many hydronium ions, what we're really measuring is the concentration. And remember, concentration, how we measure that is through molarity, or big M, which remember is moles per liter. So we're talking about how many moles of those ions do we have per liter, or that volume of that solution that we're talking about. And this right here is just another way to represent concentration. So in terms of formulas, I'm actually going to be crossing some of these out. So therefore, there are actually no new formulas that you're going to be using. You will still be using big M for molarity. And again, here's the triangle. And you will also be converting between milliliters and liters. So remember, let's say we have 50 milliliters and we want to get that into liters. You would move the decimal 1, 2, 3 places to the left. So this would be the same as 0.050 liters. So that's one way that you can convert. You can also set up a picket fence as well, using this as your equality. So these are the really only two formulas that we're going to be using. And therefore, we're not going to be using any log functions or the E function on our calculator. Now let's talk about what a titration is. This is our focus for today. Now, this is a method or an experiment that will be carried out in a lab to determine the concentration of an unknown acid or base. And this is done by neutralizing it with a known concentration of acid or base. Now remember, when you add an acid and base together, they're going to neutralize each other. So that's the type of reaction that we're talking about here with titrations. And when they neutralize each other, you will always get water as one of your products. And then whatever's left over, so again, this H will dissociate, this OH will dissociate, that will form your water. Whatever is left over is your salt, which essentially is an ionic compound. In this example, literally salt, NaCl. Now, how do you know when you've completely neutralized all of the acid or base? Or I'm sorry, you know you've completely neutralized the acid or base once you reach the equivalence point. Now, what is the equivalence point? This is when you have those two solutions, which is your acid and base, present in chemically equal amounts. This does not mean that you have the same volume present of the acid and base. This means that chemically they are equal. So that means that you have the same number of moles of the acid, which is those hydronium ions, and the same number of moles of the base, which would be those hydroxide ions. And chemically, they'd be canceling each other out, because the concentration of the unknown and the known can be different from each other. Now, how do you know when you've reached the equivalence point? So we're going to use an indicator, and these indicators are different from what we've talked about earlier. So earlier we talked about indicators that tell us the pH. These indicators are going to tell us when we've reached what we call the endpoint. And the endpoint is essentially happening at the same time as the equivalence point. So this and this will essentially occur at the same time. And you know you've reached the endpoint when you've had some type of a color change. Now, the color change that we're going to be focusing on and the indicator we're going to use in all of our examples is what we call phenolphthalein. Phenolphthalein is used to determine an unknown concentration of acid in particular. And in the video that you will watch for homework, they'll explain that a little bit more. But essentially, that indicator is clear when it is in the presence of an acid. And once that base is added to start to neutralize it, it will turn this light pink color once you have reached the end point. So again, you're going to watch this video for homework and answer some questions, and they'll go over more in detail what a titration actually looks like. But here's kind of an overview to at least get you guys started. So in this flask here, you have your unknown concentration. In this example, since it is pink for that phenolphthalein, which is the indicator, this would be an unknown concentration of acid. And then this, what we call a burette, contains the known concentration, in this case, of base. And we are slowly going to release that into the flask. I mean, in these reactions, like, you have to do seriously drop by drop at a time, because you don't want to go past the endpoint. And with the phenolphthalein, you want it to be this lovely light pink color. When it turns this really dark magenta, you know you've gone past the endpoint and the equivalence point, and therefore your calculations will not be accurate. So you slowly release that base, which you know the concentration of, into the flask to neutralize the unknown concentration of acid. Now the thing is you know how much of the known concentration of base that you're adding. You also know its concentration, and you knew the volume of this before you started. So using all those pieces, you can determine the concentration of the unknown, which in this example is the acid.